Hello everyone, my name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, and sometimes about software engineering in general. So, if you have been liking the kinds of videos that I make, you should consider subscribing to the channel and you should follow me on Twitter as well. In this particular video, we are going to talk about what are what is API machinery and what are some of the types or methods that can be used to write client Kubernetes applications. Now, if we talk about some of the previous videos, we discussed that API machinery has the implementations of Kubernetes API types. Now, if we talk about Kubernetes API type, we don't specifically have a term or construct type in case of API machinery. So, if we talk about how type uh, is mapped to something in API machinery, or if there is a similar term in case of API machinery. So these are all the things that we are going to look into. When we talked about a Kubernetes object, we also discussed about what are all the properties or behavior a particular Go type or Go struct should have, so that we can call it a Kubernetes object. In case of API machinery, the term analogous to Kubernetes type is kind. So if we talk about kinds are, as I said, analogous to Kubernetes types and are represented in camel case. So for example, if we have to specify kind for pod, this is how we are going to specify that. Or for deployment, this is how the kind is going to be represented for deployment. Now, kinds are obviously grouped in some groups. For example, apps group or authorization group, things like that, and they are also versioned. So for example, if we talk about deployments are from apps group and they are from v1 version. So this is how the term group version kind comes into picture. So if we talk about group version kind, we can say that group version kind is a way to present a particular Kubernetes object using API machinery. Now, and in case of deployments, obviously group is going to be apps, version is going to be v1, and kind is going to be, sorry, not deployments, deployment. I removed s from there because that's pretty important in case of kind. So kinds are not plural, they are camel case types, I would say, right? The other thing that I wanted to talk about is these kinds are not actually mapped one-on-one with a particular HTTP endpoint. Now, when we run a kubectl command, let's say kubectl get pod, in that case, eventually we are going to make an HTTP endpoint, and then we are going to call or make an HTTP request to that particular endpoint. So these kinds that we see here are not mapped one-on-one. When I say one-on-one, I mean there are chances that a particular HTTP endpoint and a particular kind, let's say status, this particular status can be part of many HTTP endpoints. So here we have one to many relationship between status and HTTP endpoint. The thing that I'm trying to emphasize here is there is no one-to-one mapping or relationship between kind and HTTP endpoint. And yeah, as we have already discussed, kinds are represented as camel case and singular, in most of the cases, singular uh, fields or values. If we talk about the other construct that is very similar to kind, that is resource. Now if we talk about resources are similar to kinds, but they are represented in plurals. So for example, if we talk about resource for deployment, it is going to be deployments, and that is the reason I removed s from there. So it is going to be in most of the cases lower cases and plural. So in other words, it is going to be plural version of kind. Now, unlike kinds, deployments are actually directly mapped to a specific endpoint. So for example, if we talk about uh, a resource, let's say deployment, and if we talk about the URL that gets called when we run kubectl get deployments, this is the URL that is being formed. And if we copy this URL and we observe this for a bit, we can see that this is how the URL is being formed. APIs, group, version, namespaces, namespace name, and obviously resource. So this is, as you can see, this is the resource. Now, like kinds, deployments are, or sorry, resources are also grouped and versioned. So deployments, if we talk about this particular resource, that is deployment, this is from apps and apps group and version v1. And as we have already seen here, using resources, we can very easily figure out the HTTP endpoint. For example, if we talk about services, so services are from, let's say, core API group. So for core API group, this HTTP endpoint is going to be a bit different. That's why I'm not taking an example of core API group, but let's just go ahead and try to have a look into an example of replica sets. So here we go: APIs, apps, v1, namespaces, and replica sets. And as we see here, group is apps, version is v1, namespaces, and namespace name, and then replica sets. So if we talk about resource name for replica set, it is going to be replica sets. So these are two ways using which we can represent or specify a Kubernetes object. Like we have GroupVersionKind here. Similarly, in case of resources, we also have GroupVersionResource. And as we have seen, resources are also grouped and versioned. Now, if we talk about, let's say we have kind, we have resource, how do we for example convert one? For example, if we have GroupVersionKind, how do we convert GroupVersionKind to GroupVersionResource if there is a need for this particular conversion? And that is where REST mapping comes into picture. So now let me just go ahead and open this module from, if you see, API-Machinery, package, API, meta, and REST mapper. So if you see here, we can use REST mapping's implementation. So REST mapper is a type interface, and we have REST mapping method. And if we provide REST mapping a group kind, and in that case it is going to get us REST mapping, and from REST mapping we can easily figure out group version resource. So REST mapping is obviously resource, group version kind, and scope. So if we call REST mapping specifying group kind, we are going to get REST mapping struct, and REST mapping is obviously, REST mapping has group version resource. So that is how we can very easily convert a group version kind to a group version resource. And this is why this particular REST mapper interface is very important. Now, if we talk about some of the other methods of this particular interface, for example, kind for, and resource for, it takes group version resource and it returns group version kind. So again, there are chances that if we have a specific resource, we can pass resource and we can get group version kind. Now if we look into this particular group version resource struct, it obviously has three fields, but it's not necessary that we have to specify all these three fields when we call kind for. And that is where we have the comment says partial resource. I mean, kind for takes partial resource and then returns the single match. So yeah, if you have, for example, uh, if we talk about resource, if you have pods is a resource, and if we pass kind for and then pods, it is going to get us group version kind for pods resource. So that is where all these methods from REST mapper interface can be used. uh, yeah, the other thing that I wanted to talk about is, so we talked about kind, resources, REST mapping. The other thing that I wanted to talk about is scheme. So for example, let's say in one of the previous videos, we looked into what does it mean for a ghost struct to be a Kubernetes object. Now let's say we have a Kubernetes object and we want to have group version kind for that particular Kubernetes object. So we have an instance of pod struct, let's say, and we want to convert that to group version kind, and that is where scheme comes into picture. So if we go ahead again to API machinery package, and if we this time go to module, package and runtime, if we look into type scheme, if you see here, this is type scheme, and if we look into methods for type scheme, there should be a method named as object kinds. So let me put this into the perspective of the Kubernetes object. So as we discussed, we have a ghost struct, let's say, that has all the behavior that is required for it to be called as Kubernetes object. Now we want to convert that, or we want to treat that object as group version kind, so we can use object kinds from API machinery to convert that to group version kind. So if you see here, object kinds takes an object and it gets us group version kind, and that is what we have been talking about. So now that we have group version kind for a Kubernetes object, if we want to convert that to group version resource, we can easily do that using REST mapping. Right now, another important thing that I want to highlight here is, this is only going to work if your Kubernetes object is already registered, and we can do that using add known types. So this is how we can register our Kubernetes object. And once this particular Kubernetes, any specific Kubernetes object, for example, let's say if we want to introduce another object, let's say type db struct, what we'll have to do is we'll have to first register this type using add known types. And once we have registered the type using add known types, we can use object kinds to figure out the group version kind for that particular object. And we are going to look into these things in much more detail when we try to write an operator, or when we try to write custom controllers for CRDs. So we are going to look into these things, specifically registration part in much more detail in that case. So if I try to summarize this very quickly, so you have a go struct, and this go struct can be registered. This go struct can be registered using add known types, and once this has been registered using scheme, we can convert this to a particular kind. So using scheme, we are going to convert this to, let's say, group version kind. And once it has been converted to group version kind using rest mapping, we can convert it to group version resource. And once we have group version resource, we can very easily figure out the HTTP path to which we want to query. So this is very brief summary about what we have just discussed. So we have a ghost struct that we want to treat as Kubernetes object. So we will have to implement sub methods. For example, deep copy object, we have already looked into this, and set group version kind. And once we have that go struct, we have to register that using add known types, and once it has been registered, we can call object kinds from scheme to get group version kind. Once we have group version kind, we can use rest mapping to get group version resource, and once we have group version resource, we can easily figure out the path to which we want to talk to get that particular resource. So yeah, I mean, this is what I wanted to talk about in this particular video. If you think this is going to be useful to your teammates, classmates, uh, you should share it with them. You should follow me on Twitter. Thank you for watching. I'll see you in the next one.